Hi everyone, here's your homework help video for Chapter 2, Lesson 3. Find the quotient. So we're just using our integer rules here. A positive divided by a negative, that's different signs, so our quotient's going to be negative. And 12 divided by 6 is 2. For question number 3, our integers are both negative, so they're the same. So a negative times a negative is a positive, and 42 divided by 7 is 6. For question number 7, we are just going to multiply. Right off the bat, we're going to see that there are 5 digits that will come after the decimal point. So then we can just multiply 13509 times 549. 9 times 9 is 81. 9 times 0 is 0, and 8 is 8. 9 times 5 is 45. 9 times 3 is 27, and 4 more is 31. And 9 times 1 is 9, plus 3 is 12. Now we'll move on to the 4. So we're done with the 9, so we'll put a 0 for a place value. 4 times 9 is 36. 4 times 0 is 0, and 3 is 3. 4 times 5 is 20. 4 times 3 is 12, plus 2 more is 14. And 4 times 1 is 4, plus 1 more is 5. Now we're done with the 4, so we'll put 2 zeros for place values. And 5 times 9 is 45. 5 times 0 is 0, plus 4 is 4. 5 times 5 is 25. 5 times 3 is 15, plus 2 more is 17. And 5 times 1 is 5, plus 1 more is 6. So now we add them all up. We have 1, 14, 14, 6, 11, 14, and 7. So we have 7, 4, 1, 6, 4, 4, 1, and we had 5 digits after a decimal point. So we need 5 digits after the decimal point here, 74.16441. Okay, number 8 is actually a little easier. 3 times 6 is 18. 3 times 0 is 0, plus 1 is 1. 3 times 0 is 0. 3 times 0 is 0, and 3 times 1 is 3. Now we did have a whole bunch of digits after the decimal point, actually 7. So we're going to need 7 digits after the decimal point in the answer. There's 5, 6, and 7. And we would have to annex in zeros ahead of that decimal point. So we get 0.00300018. For question number 15, we have to do long division, where 1 goes inside and 11 goes outside. Bring your decimal point up, and 11 goes into 1 0 times, 11 goes into 10 0 times, 11 goes into 100 9 times. 9 times 11 is 99. So we subtract and we get 1, and then we'd bring down a 0. 11 goes into 10 0 times. Subtract, bring down another 0. 11 goes into 109 times, and you can now see that you have a repeating pattern. So your answer would be 0.09 with a repeating bar above both the 0 and the 9, symbolizing that they both will repeat. For number 18, long division again, we know that whatever we get for an answer, we're going to have to write down the opposite because of that negative sign or that opposite sign out front. So we'll do 17.000 divided by 40. Bring our decimal point up. 40 doesn't go into 1 and it doesn't go into 17, but it does go into 170. It goes in there 4 times. 4 times 40 is 160. So we'll subtract and bring down a 0. 40 goes into 100 twice. 2 times 40 is 80. So we'll subtract and bring down. And 40 goes into 200 5 times. 5 times 40 is 200, so we are done. That's considered a terminating decimal, negative 0.425. And number 19, we have 1 and 5/6. So we know in our answer we're going to have 1 point something. And now we just need to do 5 divided by 6. So we'll do 5.00 divided by 6, bring our decimal point up. 6 doesn't go into 5, but 6 goes into 50 8 times. 6 times 8 is 48. Subtract and bring down the 0. 6 goes into 20 3 times. 3 times 6 is 18. Subtract and bring down another 0. 6 goes into 20 3 times. And now you can see that there is this repeating or this pattern where it's going to be 20 minus 18, 20 minus 18. And so therefore we can say that the 3 is going to repeat. So we don't even need this extra one. So we'll have 1.83333 that repeats forever. For question number 20, we can once again identify that 4 is the whole number. So that's going to be the number in front of the decimal point, which makes our life a little easier. Now we just have to do 2 divided by 15. Bring our decimal point right up. 15 doesn't go into 2, but it goes into 20 once. 1 times 15 is 15. Subtract and bring down a 0. 15 goes into 50 3 times. 3 times 15 is 45. Subtract and bring down another 0. 15 goes into 50 3 times. 3 times 15 is 45. That's established our pattern again, so we know that this 3 is going to repeat. We don't even need that one. So our answer would be 4.13 repeating. Number 22, we know whatever we get for 13/11ths is going to end up being negative. So now we can do 13 divided by 11. 11 goes into 13 once. 1 times 11 is 11, so take away and bring down. 11 goes into 20 once. 1 times 11 is 11. Subtract and bring down. 11 goes into 90 8 times. 8 times 11 is 88. Subtract and bring down. 11 goes into 20 once. 1 times 11 is 11, so we subtract and bring down. 11 goes into 98 times. You've got your pattern established, so you know the 1 and the 8 is going to repeat. So this becomes negative 1.18 repeating. And finally, for question number 24, we're going to do the 7 divided by 12. So 7 goes inside the house. Bring your decimal up, and we're going to divide by 12. 12 doesn't go into 7, but 12 goes into 70 5 times. 5 times 12 is 60. So we take away and bring down a 0. And now we could say 12 goes into 100 8 times. 8 times 12 is 96. 12 goes into 40 3 times. 3 times 12 is 36. So we take away and bring down a 0. And now you can see that that 3 is going to repeat. Let's go back to the original problem. We had negative 5 as a whole number, and our decimal would be 0.583 with the repeating sign over the 3. You be the teacher. Your friend writes negative 7/11ths as a decimal. Is your friend correct? Explain. So we have negative 7/11ths. We know our answer is going to be negative, so we're really just doing 7 divided by 11. 11 doesn't go into 7, but it goes into 70 6 times. 6 times 11 is 66. 11 goes into 40 3 times. 3 times 11 is 33. 11 goes into 70 6 times, and 6 times 11 is 66. So we annex and bring down another 0. 11 goes into 40 3 times, and so we have our repeating pattern now. But what we're seeing is that the 6 and the 3 repeat. So your friend was wrong. So is your friend correct? That would be a no. And why? Because they just put a bar over the 3, and the answer should be 0.636363 repeating. For questions 28 through 34, write a decimal as a fraction or a mixed number in simplest form. So the first thing to remember are place values: tenths, hundredths, thousandths, 10,000ths. That goes for everything. So looking at question number 28, you have a digit in the tenths and the hundredths place. So your denominator is going to be 100, your numerator is 45, and now we would simplify by dividing by 5 over 5, and you get 9/20ths. For question 30, we have a place value in the tenths, the hundredths, and the thousandths. So our denominator will be 1,000, and our numerator is 312. If we simplify, we could always start by dividing by 2 over 2. We get 156 over 500. We could divide by 2 over 2 again, and we get 78 over 250. We can divide by 2 over 2 again because they're continuing to be even numbers, and we get 39 over 125. Please always go back and look. This was a negative decimal, so therefore our fraction also needs to be negative, negative 39 over 125. For question number 31, again, noticing right away that's going to be negative. So we have a digit in the tenths and the hundredths place. So we're going to have negative 2 and 32 100ths. I see right away here that I could actually divide by 4 over 4. 32 divided by 4 is 8, and 100 divided by 4 is 25. So we get 8/25ths. We had the whole number out front, which was negative 2, so we have negative 2 and 8/25ths. And then for number 34, we have this negative 12 out front, so let's not forget that at the end. And we have a place value that has a digit in the tenths, the hundredths, and the thousandths. So we're going to have negative 12 and 405 1,000ths. I know I can divide by 5 over 5. 405 divided by 5 is 81. 1,000 divided by 5 is 200. So I end up with negative 12 and 81 200ths. And it can't be simplified anymore. There's no common factor between the 81 and the 200. On question number 36, we are comparing the rational numbers. This one's pretty nice, negative 4 and 6/10. I can write that as a decimal because there's my negative 4, there's my tenths place, so I just put a 6 in there. And I'm going to be comparing that to negative 4.65. So all I really need to do is annex a 0 in, and now I can look on the number line. I have negative 4.60 and negative 4.65 is to the left. So negative 4.65 is smaller, negative 4.6 is actually bigger. For number 37, we do have to use a little bit of long division. We have to do 3 divided by 11. Eleven doesn't go into 3, but it goes into 30 twice. 2 times 11 is 22. 11 goes into 87 times. 7 times 11 is 77. 11 goes into 30 twice, so now we see a pattern. It's going to be 0.27 repeating. So I'm going to rewrite this as negative 5.27. And we're going to be comparing that to negative 5.2 with a repeating bar. So that means our next digit is going to be a 2 as well. So now I'll graph those on the number line. Here's negative 5.22 repeating. Negative 5.27 is further to the left, so negative 5.22 is greater. Modeling real life. In softball, a batting average is the number of hits divided by the number of times at bat. Does player 1 or player 2 have the better batting average? So we're going to go player 1, 42 over 90, and player 2 is 38 out of 80. I would encourage you to simplify these right away. Divide by 2 over 2, and you get 21 40ths. 21 45ths. And then player 2, we could divide by 2 over 2, and you get 19 40ths. Now, we cannot just guess right now, though. That's something that we can't do. We have to do long division. 21 with some zeros annexed in, divided by 45. 45 doesn't go into 2, and it doesn't go into 1. It does go into 210. 45 goes into 210 4 times. 45 times 4. 4 times 5 is 20. That's 16 and 2 more is 18. So 180. So now we take away 210 minus 80, 180 is 30. Bring down a 0. 45 goes into 300 6 times. 6 times 45 is 270. Take away, you get 30. Bring down a 0. So that 6 is going to repeat. Now we'll do our long division for 19 40ths. Forty doesn't go into 1 or 19, but it does go into 190. It goes in there 4 times. 4 times 40 is 160. 40 goes into 300. It goes in there 7 times. 7 times 40 is 280. So we get 20. Bring down a 0. And 40 goes into 200 5 times. So now we've got 0.466 repeating compared to 0.475. 0.475 is bigger, so player 2 has the better batting average. You missed 3 out of 10 questions on a science quiz and 4 out of 15 questions on a math quiz. Which quiz did you have a greater percentage of correct answers? So if you missed 3, it means you got 7 correct out of 10. 7 out of 10 is 0.7, or we could say 0.70, which is a 70%. On your science quiz, you missed 4 out of 15, which means you got 11 out of 15 correct. This one's not so easy to just turn to a decimal, so we have to do long division. 11 divided by 15. 15 doesn't go into 1 or 11. 15 goes into 110 7 times. And then 7 times 15 is 105. 15 goes into 50 3 times. 3 times 15 is 45. We can actually stop right there because we know that 0.73 is 73%. 73% is obviously better, it's bigger. So therefore, we would say we did better on the science. And finally, it says a hackberry tree has roots that reach a depth of 6 5/12 meters. The top of the tree is 18.28 meters above the ground. Find the total height from the bottom of the roots to the top of the tree. So if we draw our picture off to the side, here's the tree. The roots are going down, and the roots go down 6 5/12 meters, and the tree goes up 18.28 repeating. So what we're going to need to do is we're going to need to take the absolute value of these numbers and add them together, just like we did when we found distance between numbers on a number line. What we'll have to do first, though, is convert 6 5/12 into a decimal. So we'll do 5 divided by 12. 12 doesn't go into 5, but it goes into 50 4 times. 4 times 12 is 48. 12 goes into 20 once, and 1 times 12 is 12. Bring down a 0. Twelve goes into 80 6 times. 6 times 12 is 72. Okay, and that's going to end up repeating. Okay, so now what we do is we go back and we look. It was 6 5/12. So we're going to have 6.416 plus 18.288, because that's repeating. Line up our decimal points, and now we can add. We get 14, we get 10, we get 7, we get 14, we get 2. 24.704 meters. That's how far apart the bottom of the roots are from the top of the tree.